The first concept that we need to review is the idea of conversion, or moving between one unit and another. Now, it's really important that you be able to convert because you can't always make a measurement in standard units. Whenever we're talking about a gas, a lot of times we'll refer to something by Pivnert, where PV equals nRT. And one of the measurements you make right here is the number of molecules. Now, I can't count 1.5 moles, and I can't find 6.022 times 10 to the 23rd molecules of a substance. So instead, I need to be able to measure something else and convert to a known quantity. So sometimes it's impossible to make the measurements in what you need them to be in. Another reason is sometimes we're required to use fundamental constants whenever we're calculating something. An example of a fundamental constant would be when you use the formula E equals HF. This right here refers to something that's called Planck's constant. If you don't remember this, that's okay. We're going to go over it in Unit 1. But Planck's constant is a constant. But in order to use Planck's constant, the frequency has to be in a value of hertz. Okay, that's generally pretty normal, but a lot of times frequency is reported in kilohertz, megahertz, or terahertz. So you need to be able to convert between metric quantities. A lot of times we talk about things in terms of centimeters or centimeters cubed or milliliters or liters. You need to be able to seamlessly move between those metric units. So, because of that, it's really important that you memorize these terms. Okay, the idea of a giga, mega, kilo, centi, milli, micro, and nano. We'll go ahead and throw pico on there. Pico is not something that you're going to see as often, but it is small p, it's a lowercase p, and it means 10 to the minus 12th. And that's kind of when you start to talk about the size of a nucleus, you start to talk about things in picometers. So you really do need to memorize these values in the sense that I should be able to tell you 10 gigameters, and you say, oh, well, that's 10 times 10 to the ninth meters. Okay, you need to be able to make these conversions very, very quickly because the AP test is a time test. Any time that you spent trying to remember or trying to write out these conversion factors is really going to take away from your time that you need to answer other questions. So we're going to get some practice to begin with so that we can go ahead and make these easy moving forward. So the first one is how many milliliters are in a gallon of milk? To begin with, we're going to be expected to use dimensional analysis. And so we start off with the idea that you have 1 gallon of milk, and we can say when you use a conversion factor, the things that are on top of one another need to be equal. So I can say that 1 gallon is equal to 3.78 liters. These two things are called an equivalence, so I can put them on top of each other, and they're called a conversion factor. So if I were to stop right here, gallons would cancel out, and I'd be left with liters, and I'd have 3.78 liters. But the question says how many milliliters, so I need to take it one step further, and I would say 1 liter is 1,000 milliliters. Multiply it out, you get 3,780 milliliters, and that would be your answer for how many milliliters are in a gallon of milk. The second example we have here is a little bit more complicated. It's 19.3 grams per centimeter cubed. Whenever you see grams per centimeter cubed, that's the same thing as saying grams per 1 centimeter cubed. So what I do is I say 19.3 grams per 1 centimeter cubed. And I want to take this thing and I want to get it into kilograms per meter cubed. So I'm going to start with the easy one, and that's the grams, and I can say that there are 1,000 grams in 1 kilogram. And I know that because I memorized my metric conversions on the previous slides. So now that if I were to stop here, I'd be in kilograms per centimeter cubed. But I don't want kilograms per centimeter cubed. I need to convert it between centimeters and meters. So I start off with a conversion factor that I have 100 centimeters equal 1 meter. Sorry, that's a little hard to see, but you have 100 centimeters per meter. And a lot of people will do this and they'll stop there. But remember, whenever you have a centimeter divided by a centimeter cubed, it doesn't cancel out the centimeter cubed. Instead, it cancels out the cube and turns it into a square. In order to make this conversion factor happen all the way from centimeters cubed to meters cubed, you need to do it 3 times. So you say 100 centimeters, 1 meter, 100 centimeters, 1 meter. Whenever you do this, you now have meters 1, 2, 3 times on the bottom, which makes it meters cubed, and you have centimeters 1, 2, 3 on the top, which cancels out with our original centimeters cubed. So if you look, when we go from grams per centimeter cubed to kilograms per meter cubed, it's going to be 19.3 times 100 times 100 times 100, which 100 times 100 times 100 is a million. So it's a million divided by 1,000, Well, when you divide by 1,000, okay, whenever you divide by 1,000, these three cross out, and so you're basically multiplying by 1,000. So you end up with 19,300 kilograms per meter cubed.